Okay, this is Unit 5, less than 11. Okay, how is addition property of equality similar to the addition property of inequality? Yes. Ola, how are they similar? Okay, that's very good. Here's what the book gave us for an answer. You can add each side of an equation or inequality without changing the relationship. It's still a true relationship, right? Okay, now solve each inequality. So who has the answer to this first one? Caleb, go ahead.
You subtract 3 from each side.
Right, so we're going to use the subtraction property of inequality. We're going to subtract from each side of the inequality, and then what do we get back?
So we get x is less than or equal to 2.
Very good. And then this is what we end up with, and then additive property, identity, addition property of identity, this is what we get. The identity property of addition, this is what we get. Okay, who's got this one over here? Timothy in the back, go ahead.
You add 9 to both sides.
Nice, we're going to add 9 to both sides. What do we get back?
3 plus 0 is greater than or equal to 7.
Right, and then p plus 0 becomes what?
P is greater than 7.
Great, very good. And who's got this one over here? 8 is greater than or equal to d plus 5. Fatima?
So you're going to subtract from both sides.
What are you going to subtract?
You're going to subtract 5.
Very good. We're subtracting 5 from both sides. What do we get back?
You get 3 and 0.
Okay, right. So we get 3 and 0. So 3 is greater than or equal to d plus 0. And then that simplifies to what?
3 is greater than or equal to d.
Very good. Okay. Any questions so far? Okay, next step. Norwood, yes.
So I have use addition property.
Right. And what are we going to add?
Add 2.
Add 2 to both sides. Very good. What do we get back? This is tricky. Be careful of the signs.
Get that 0 and -10.
Not negative 10. When you have different signs, we take what? Different signs, what do we do, class?
You take the subtract.
You take the difference. What's the difference of 8 and 2?
6.
It's 6. And then 6, the number, we have to assign a positive or a negative to it. Do you know which one? And why did you say negative, Alexis?
Because
8 is a greater magnitude than 2. It's farther from 0. So we're going to keep the sign of the 8, which is negative, so negative 6. Okay? And then my last step, identity property of addition, r plus 0 is r. R is less than negative 6. Okay? Any question about the warm-up? Okay, let's move on. Here we go. Now we're going to learn some new properties. I'm going to go ahead and read this since I'm making the video this period. What you'll learn: to solve inequalities by multiplying or dividing. New vocabulary: division property of inequality, multiplication property of inequality. Why learn this? Inequalities can help you plan. You can solve inequalities to make sure you have enough ingredients when you're cooking. Look at the pattern when you divide each side of an inequality by an integer. So let's take a look at this. Everybody see the post-it note okay? Okay, so I have the same inequality, but I want you guys to observe something. So what am I doing to both sides of this inequality here? Dividing by 6. Let's go ahead and simplify it. 18 divided by 6 is what? 3. And 12 divided by 6 is? Okay. So class, is this still true? Is 3 greater than 2?
Yes.
Okay, so we have something that's true here. Take a look at what's... This is an integer. What other things do we notice about this? What other thing about what do we notice about the number 6? Ola.
Like denominators?
Yeah, we're dividing from both sides, right? The same number, but what else do we know about the number 6? What's the sign of it? It's positive, okay? So over here we're going to do something else. I'm going to go ahead, and what am I doing to both sides of the inequality? Dividing by 3. Okay, well, divide by 3. Here's what we get. 6 is greater than 4. Is that still true? And that's still true, yes. Now I want to try something different. So we divided this inequality by a positive number. This inequality we divided by a positive number. Watch what happens when we divide by a negative number. What's 18 divided by negative 2? Negative 9, because when you divide different signs, you get back a negative, right? And so 12 divided by negative 2 gives me back what? Negative 6. Now, is this true? No. That's false. Negative 6 is actually closer to 0, so that is greater. So we have a false statement. So what can we do to make this a true statement? How would I fix this? Joshua?
Changing the negative 2 to positive.
No, we're not going to change the numbers. We could change something else. Timothy?
You say 9, negative 9 is less than negative 6.
Nice. We can fix it like this. Now it's true. Do you see what I just changed to make it true? Okay. Remember I told you there's one thing different about inequalities than solving equations? This is the one thing. I divided by a negative, so I had to change the direction of my inequality. Now, if I divide both sides of this inequality by negative 6, what do I get back? Negative 3 is greater than negative 2. Is that true?
No.
How do I fix that?
Change the signs.
What sign?
The greater than,
I got to change the greater than to what?
less than.
Right. So if we fix that, here's how we fix that. Do you guys see how we fixed it? So if we multiply or divide by a number, if it is a negative number, I have to change the inequality. If it isn't a negative number, I don't have to change it. It'll still be true. Do you understand? So here's the rule. When the integer is positive, the direction of the inequality stays the same for a multiplication or division property of inequality. But when the integer is negative, the direction of the inequality is reversed when you multiply or divide by a number. If that number is negative, you have to change the direction of the inequality. You guys understand? That's the one little difference when it comes to solving inequalities versus equations. Understand? Okay, any questions so far? Now, here's the division property of inequality. If you divide each side of an inequality by the same positive number, the direction of the inequality symbol remains unchanged. So here, if I divide both sides by, in this case, I divide by a positive 3, my inequality didn't have to change. It's still true. That's true of any number. That's also true algebraically. So if A is greater than B and C is positive, then I don't have to change the direction of my inequality if I divide both sides by C, because C is positive. Here's another example. If 15 is less than 20, I can divide by a positive number, and I keep my inequality the same direction. That's same algebraically. But here's the catch. If you divide each side of an inequality by the same negative number, the direction of the inequality symbol is reversed. So if you take a look at here, 16 is greater than 12, but if I divide by a negative number, I have to change the direction of my inequality. Do you guys see that? Here's what that says algebraically. Similarly, if you have a number that's less than another number, if you divide by a negative, you got to change the inequality from less than to greater than. You guys understand? That's the one thing you have to pay attention to. Now, let's put this in practice. Here's what I want you guys to work out. This problem right here. Solve it and graphic. Yes. Logan. Would anybody like to walk us through this? Somebody I haven't heard from yet would be nice. Miles, can you take a guess on how we're going to do this? A lot of it's the same as solving an equation. We just got to remember that one special situation where we do something with my inequality. So what's my first step? How do I get my variable by itself in this inequality? What am I going to do? I have to undo something, right? What am I going to undo? What's that? Yeah, you're looking at the negative 3y. What's happening between negative 3 and y? What's happening between negative 3 and y in that inequality? Well, negative 3 is being multiplied by y, but the opposite of multiply by negative 3 is what? Is divide. So to get y by itself, I have to divide both sides by not 3. Do you see a 3 there? What do we see there next to y? It's not 3. What is it? No, next to y. What's next to y? It's a negative 3. You can't change the sign. Whatever you're getting rid of, keep that, use that. So I'm multiplying by negative 3 with the y. To undo that, I divide both sides by negative 3. Now, if we divide both sides by negative 3, I have to do something to my inequality because negative 3 is not a positive number. So take a look. Look what happened to my inequality. You guys see that? Now, let's go ahead and simplify that. What happens to this left-hand side of my inequality now? Miles? What is that going to become? It becomes what? What's something divided by itself? Right, so this side becomes a 1y. And then what's negative 27 divided by a negative 3? Becomes just a 9. Very good. So here's what we got. There's my 1, and that's greater than 9, positive 9. Y is greater than or equal to 9. Can you tell me, what is that graph going to look like? So here's my number line. Open circle, closed circle. Closed circle, very good. And where's my closed circle going to be? It's going to be at the 9, very good. And here's where 9 is on the number line. And am I going to shade to the right or shade to the left? No, left would be less than. If I put a number left of 9, pick any number left of 9. 8. Is 8 greater than or equal to 9? That's false. So we wouldn't shade that way. We'd shade to the right. Okay, do you see how you're going to test numbers and figure out which side to shade to when they return? Yeah, that's fine. Okay, any questions about that example? You see how everything's the same for solving equations except for you have to change the direction of the sign when what? If we're multiplying or dividing by a negative number. Okay, moving along, next example. I want you to try these two problems right here. Solve them and graph them. Try it, and we'll talk about it in a moment, but try it on your own. Can you guys see that bottom problem here? Okay. So there's actually 3 of them. Daniel. Is there anybody still working on the first problem? Okay. Can somebody walk me through the first problem then? It looks like everybody's done with it. Fatima, what's the first thing I need to do?
So first thing you're going to do is divide both sides by -4.
Yes, I'm going to divide both sides by -4. But when I divide both sides by -4, something has to happen. What's that?
Change the less than 10 to
Right, we're going to change the less than sign to a greater than sign. So does everybody understand that step? We're good? Okay, now go ahead and simplify it.
So
So negative 4 divided by negative 4 becomes a 1. 36 divided by negative 4.
Students, please pardon this interruption.
Negative
Just
9, very
wanted to
good.
let everyone know that this morning, Mr. Kubo and myself have been having some talks with some of our student leaders here in the building, specifically some of our SGA members and other leaders that are in the building. And our SGA high school president, Ms. Kaya Patterson, has offered some words and has volunteered to come up and speak to our student body this morning.
Okay, good morning. I want to start out by saying that Mr. Baker didn't tell me to make this speech. I volunteered. I think that it's important that everyone knows that today is a day that could create change in someone's life, one way or another. I know a lot of you are ready to protest the election of Donald Trump, whether it is to sit in or walk out. You are young adults who make your own decisions that affect your life. I actually am so happy that a lot of you decided together that we're not going to take this anymore, and we will unite together and make sure we're heard. I commend you for that. Just promise me that you will carry yourselves with dignity and maturity while protesting peacefully. Malcolm X, a man of action, would be proud to see such a wonderful group of young men and women who see something they don't like in politics and do something about it. As for the ones who don't participate, I commend you for your decision as well. Martin Luther King, a man who believed we are armed with our intelligence, would be so happy. Whether you stay or go, that is your decision and yours alone. Just know that once you step out those doors, we can't ensure your safety. There's this thing called the butterfly effect, basically stating that whatever choice you can make can affect something, and that can affect something else, so on and so forth. Whether you leave or stay, know that you are making them fall back, slowly but surely. There's nothing a man like Donald Trump fears more than people coming together to make a stand against him. You can be the Malcolm X, the person who takes a stand and knows that you can't just sit on your butt and complain about the lack of change. You can be the MLK, the person who waits for their time and knows that the best revenge are the ones who push them down to their own success. But together, united, we are a force to be reckoned with. I can't promise that if you step out those doors, racism will stop in its tracks, nor if you stay in your seats. What I can say is your decision today will help. It will help this country realize that we are all people capable of anything we can set our minds to, no matter the color of our skin or the religion we follow. In the world, in this school, there's an amazing group of diverse young men and women who today I trust to make the decision best suited for them. I started negotiations with Mr. Baker about creating a safe and secure peaceful protest where we can all exercise our rights to freedom of speech. Please know that we all understand the importance of doing this sooner rather than later. Mr. Baker and I are in agreement that all people need a safe and productive platform to be heard. Have a good day.
Okay, Fatima, how would I go about graphing P is greater than negative 9? Very good. Open circle at negative 9, and which way am I going to shade? To the right, very good. Open circle at negative 9, shade to the right. If you have a question about which way to shade, you look at the number. Once you've isolated your variable, negative 9, plug in a number, pick a number on the left-hand side or the right-hand side. So if we picked on the left-hand side and put negative 12 here, negative 12 is not greater than negative 9, so that's false, so we wouldn't shade this way. Understand? So whatever number you pick, if it's false, you know not to shade in that direction. If it's true, you know that's the direction to shade. So if we picked any number to the right of negative 9, negative 6 is greater than negative 9, so that would be true, so we would know to shade to the right of the open circle. Okay. Let's go ahead. Who wants to walk me through this problem? Logan? Oh, anytime you divide by a negative number, you have to change the direction of the sign to make it true. Okay? The inequality has to change the direction. If it's a positive number, Logan, you just leave it. That's the only, remember I said solving inequalities, there's only one thing you have to be careful of. That's the one thing. Okay? That's the only thing that makes solving equations different from solving inequalities. Okay? Uche, can you take me through the next one? Okay, what's the first step?
So first you would change the sign from greater than or equal to less than or equal to.
Okay, so we're going to change the inequality, but why are we changing the inequality? We don't just always change the inequality.
Because both denominators are negative.
Because we're going to divide by a negative number, we have to change the inequality's direction. Do you guys understand? Mm-hmm. Okay, so now what happens when I simplify that? right? Negative 8 divided by negative 8 becomes 1. And what about negative 24 divided by negative 8? It becomes a positive 3. Very good. And then m over 1 is just m. Now, what does that graph look like? Can you describe to me what that's going to look like?
It's going to be a closed circle.
Very good. Closed circle where?
Where 3 is.
At 3, here's 3. And which way am I going to shade? So remember how we test it. How do we test it? I look at 3. I pick a number on one side of 3. Which side do you want to test? Right or left side? Okay. So on the right-hand side, can you pick a number right of 3?
4.
Okay, so you're saying 4. If I put 4 in here, is that true? Is 4 less than or equal to 3?
No.
Okay, so since that's false, I know I'm not going to shade this way. Understand? I have to shade the left way. Does that make sense? Do you guys see how we test it? Okay, so you knew whether it was going to be open circle, closed circle, but now I need you to understand how do we test it out. Do you want to walk me through this, or do you have a question?
I have a question.
Okay. Okay, go ahead.
So would the less than or greater than sign determine which way, like, you're going with the arrow? Because I noticed, if you're going to the less than sign, you're going to the left of it.
You can't go by that because, I'll give you an example. 3 is greater than or equal to m. So it depends on the way they write it. You just, if you substitute numbers to the right or the left of that, in this case 3, you can test to see what's true and then shade in that direction. Okay? Okay. Who can walk me through this? Oren, I haven't heard from you. Can you walk me through it?
So you're going to divide by +7.
Dividing by +7. Okay, do I need to change my inequality then? No, since it's a +7, I don't have to change my inequality. So go ahead. What's that going to simplify to?
n over 1 greater than -3.
Nice, n over 1 greater than -3. And what is this simplified to?
N greater than -3.
Right, n is greater than -3. And so if we graph this, what's that going to look like?
It's going to be an open circle.
Very good, open circle. Open circle where?
Face to the right.
Open circle at -3, and we're going to shade to the right. Are we good? Any questions about that? Okay, let's move right along. Next problem, now we have some word problems. Application, planning. Your class is taking a trip to a museum that is 190 miles away. The bus can travel at 55 miles per hour. At least how many hours should your class plan for the trip to the museum? Okay, well, if you're driving, who can walk me through that? Ola, go ahead.
It's going to be the 55H
Okay. H represents what?
hours.
How many hours, right? So I like that. You're going to let H represent your hours. And you're saying 55 times H?
Yeah.
Okay. And what inequality you're going to use? They say it in there, right? At least, right? So is at least how many? At least how much? 190 miles, okay? Now, what symbol will we use for at least?
Less than or equal to.
Very good. Actually, at least means it can be, right? If I say I have at least $5, can I have $6? Think about that. I have at least $5. Can I have more than $5 if I can have at least, right? So think about that. Is at least. So that's going to be greater than. You guys understand? Okay. So now here's my inequality, and we're going to go ahead and, you guys know how to solve this, right? What am I going to do? Divide by 55. And do we need to change our inequality? No. Why not? Because it's positive. Ola, I'm talking to Ola. Shh. Okay, so we're dividing by that. I'm just going to go ahead and tell you guys what the result's going to be. It's going to be 3 and 45 hundredths repeating. And so the number of hours is 3 and 45 hundredths. And then that's almost, remember 0.5 tenths is half, right? So that's why I said your class should plan for at least 3.5 hours or 3 hours and 30 minutes. Yes, Caleb?
So the bar means that it's repeating?
That was a repeating decimal, yes. But I'm not going to get into that. We're almost out of time. Okay, moving out. A long-distance telephone company. Let's go ahead and try to work this out. You guys do this on your own. A long-distance telephone company is offering a special rate of 6 cents per minute. Your budget for long-distance telephone calls is $25 for the month. At most, how many minutes of long distance can you use for the month with this rate? Who thinks they know how to set this up? Go ahead. Give it a shot.
Okay, so this is personally what I did.
Okay.
What I did was I multiplied 6 by 100, giving me $6.
Uh-huh.
Which means it's definitely more than 100.
Okay, so you're not really coming up with an equation. You're not coming with an equation. Let's try or an inequality. Let's try to come up with an inequality. So you have a plan, and I think you're trying to figure out, okay, how much would I spend if I had 100, right? But we want to get an exact value, okay? As close as possible without going over. Go ahead. We don't want to estimate. It sounds like what you're trying to do is to estimate. Go ahead. Right. So 6 seconds per minute. We're going to multiply that rate times the number of minutes. But do we know what number of minutes we have? No. We're trying to figure out how many of those minutes are going to be. So you're using M for minutes. I use the same variable. Okay. And then what did you use for your inequality? What's that? It's going to be less than. Okay. Your budget is 25. Does that, if your budget's 25, can you spend 25? What's that? Okay. So would it just be less than? It'd be what? It can be less than 25, but can we also spend 25? All right. So it'd be less than or equal to, right? At most. Okay, so here's what we have. And then you divided both sides by 6/100. Okay. And then here's what we get when we divide that out. I'll just tell you guys right now. It's 6 repeating, 416 and 6/10 repeating. And so the answer, because they're not going to bill you for part of a minute, they're going to bill you per minute, and you don't want to go over. So 416 minutes is the most you can talk without going over your budget. Got it? Okay. If we round this to 417, it'd be just a little bit more than $25. So that's why we didn't round that up. Okay, moving along. Guess what? Multiplication property of inequality. It's the same thing. If the number you multiply both sides by is a negative number, guess what you got to do with your inequality? Change the direction. So let's go ahead, solve these two, and graph it. Quickly solve these and graph. Okay, who wants to walk me through this first one? How do I get my y by itself? What am I going to do? Terrell, I know you know this. Walk me through this. Yeah, okay, you could put 2 over 1, or, because you're wanting to work with fractions. Okay, that'll work. But what's going on with my y and my negative 8? What's happening between those two things? I'm dividing by negative 8. So how do I undo divide by negative 8? I got to multiply by negative 8. So if I multiply by negative 8, do you see what happened?
Yeah.
I had to switch my signs. Do you guys understand? Okay, so very similar to what we did for equations, except for we just have to be aware of what happens to the inequality. Now, what happens to this side of my equation, Terrell? It becomes what?
You multiply across.
Okay, and what do we get back? No. Oh, well, this one becomes negative 16, right? But what happens to this side of my equation, my inequality?
Y, and 1y.
Y over 1 or 1y, right? And so that simplifies to y. And so can you tell me what's that graph going to look like?
It's gonna be closed circle going to the left.
Closed circle at 16, negative 16, and it's going to the left. Are we good? Okay. Can I get a volunteer for the next problem now that you've seen one worked out? Somebody I haven't heard from would be nice. Rudy, I haven't heard from you. Can you walk me through this problem? How do I solve this?
So you have to, since 5 is negative, you're going to change the inequality.
Right, we're going to change the direction of the inequality. And what are we multiplying by?
We're multiplying by 5.
We're multiplying both sides by negative 5. So notice I changed the direction of my inequality. I'm multiplying both sides by 5. This side, I changed my negative 5 into a fraction, but I'm still doing the same thing to both sides. And then I also changed my inequality. Okay, now what's next?
Then you multiply negative 4 times negative 5, which is positive 20.
And so this becomes positive 20, very good. 2 negatives become a positive. And then that simplifies. Here's what we have. And then k is greater than 20. How does that look like on the number line? Not negative 20, you said it was positive. Closed circle at positive 20. Please turn around. And then what? To the left? Well, let's look at numbers to the left of 20. Pick out a number on the left-hand side of 20, any number. 19. So if I put 19 here, is that true? Is 19 greater than? So do you see how you know not to shade that way? You know you're not going to shade left because that was false when you put in 19. So you're going to shade to the right. You understand? Okay, question.
I thought it was an open circle.
Yeah, it is open circle. Oh, I said close. I meant open circle. What I have here, it's not equal to 20, open circle at 20, shade to the right. Okay? Any other questions? Okay, we're home stretch. We're almost done. Okay, what happens when you multiply each side of an inequality by a negative number? What happens? Somebody... Jonathan, what happens if I multiply 2 sides of an inequality by a negative number? What happens to the inequality? I have to flip it. I have to change the direction. The inequality symbol is reversed. Okay? Now, if this is true, if x is greater than y, which statement is not always true? Is this going to be always true or not always true? Always true. It's the same thing. They just changed the thing around and they moved the y to one side, the x to the other side, and they changed the direction of the inequality. That is always true. How about this one? That's always true. Why? What is that property they're showing? Addition property of equality. That's always true. What about this over here? You're saying yes? What property is that? Subtraction property of inequality. That is always true. How about this one? Is this always true? No. Why isn't it not always true? Because multiplication and z, if it's positive, is it true? If z is positive, is that true? Yes, but if z is negative, it's not true. You got to change the sign. So that's sometimes it's false. Understand? Because if z is negative, you have to change the direction of the inequality. Okay, moving along. Tell me what goes here. What's the inequality that goes here for this one? If I have 3m is greater than 99 and I divide both sides by 3, what's the inequality going to be? Alexis? Less than? Why do you say less than?
Oh wait, no, it stays the same.
Oh, you're changing it. Why do you say it's going to stay the same?
Because it's a positive number.
Because those are positive 3s we're dividing by. That's right. It's going to be greater than. It's going to stay greater than. Who's got this one? Who can walk me through this one? Tayana, what do you think is going to be?
Maybe 10.
No. Don't solve it. What's the inequality going to be?
It's gonna be less than or equal to.
So you think it's going to stay the same? Why do you think it's going to stay the same?
Like no, I mean it's gonna be changed.
It's going to be changed to what? So it's going to be changed from less than or equal to greater than equal to, because and why is that? Because we're dividing by negatives. Okay? And who's got this last one? Saki, can you get the last one? Right, we're multiplying both sides by -3, so we're going to change the inequality to greater than.